Hello student, good morning all of you. This is a lecture for B.Sc TY student. B.Sc TY and semester is 5th semester. Chapter is 3rd. No, chapter is 4th. Chapter is 4th, and our topic is eigenvalues and eigenvector. Eigenvalues and eigenvector. So student, we are going to discuss what is meant by eigenvalues and what is meant by eigenvector. Okay. Now we will discuss here definition of eigenvalue. So what is the definition? If A is a square matrix, see here, if A is a square matrix, A is square matrix. Okay, A is a square matrix of order n. So here order is n means there are n row and n columns. There are n row and n columns. Then the value of lambda for the equation Ax is equal to lambda x. I say this equation is equation number 1. So A is any square matrix. See here, A is any square matrix of order n. Then the value of this lambda for the equation, if we make this equation Ax is equal to lambda x, and after solving this equation we get some values of lambda, and these values of lambda is nothing but eigenvalues. But it is necessary that, so this equation has non-trivial solutions. So this equation has non-trivial solution and are called the eigenvalue of A. And if lambda is an eigenvalue, then for corresponding x is called eigenvector. It's called eigenvectors. Then we get the corresponding value, and that corresponding value is called as eigenvector. So there are some similar names for eigenvalues. So eigenvalues is also called as characteristic value. or proper value that means this lambda is nothing but the characteristic values, proper values and eigenvalues. These three names are similar and we use these three names for eigenvalue, and in the same way we can use characteristic vector, proper vector, name for eigenvector. So here determinant of a minus lambda I is equal to 0. We call this equation as second. So eigenvalues lambda are simply the root of this algebraic equation. If we solve this algebraic equation, determinant of a minus lambda I, where this a is nothing but square matrix of order n and I is nothing but identity matrix of order n. So this identity matrix is depend on this matrix A. If order of the matrix A is n, then order of matrix I is n. If order of matrix A is m, then order of matrix I is n. So that means order of the matrix I is depend upon order of matrix A. So this determinant of a minus lambda I, after solving this, or after if we put a minus lambda I, or if we put all values here, we get one polynomial in lambda. We get polynomial in lambda, and polynomial in lambda, after solving that polynomial we get the values of lambda, and that is nothing but our corresponding eigen values for that matrix. Now we try to discuss one problem example. See here one example I am going to discuss. So this is the matrix A is equal to 1 minus 1 2 0 1 0 1 2 1. This is a matrix of order 3. That means it has 3 rows and 3 columns. 3 rows and 3 columns. Be carefully listen. If the matrix is a square matrix, then we can find